Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. Akash has a liability of $6,000 due in 4 years. This liability will be met with payments of A in 2 years and B in 6 years. Akash is employing a full immunization strategy using an annual effective interest rate of 5%. Calculate the absolute value of the difference between A and B. And here's a solution. The Macaulay duration of the liability is 4 because it's a single payment of time 4. Assuming equal values of assets and liabilities, the total value of liabilities is known as 6,000 times 1.05 to the negative 4, so that's the total value of assets. And assets present value are A times 1.05 to the negative 2 for the first payment, and B times 1.06 to the negative 6 to the second payment at time 6. And therefore the Macaulay duration of the asset portfolio is A times 1.05 to a negative 2 divided by 6,000 times 1.05 to a negative 4 times 2, plus B times 1.06 to a negative 6 over 6,000 times 1.05 to a negative 4 times 6, the weighted average time until payment. And since this must equal 4, we have this equation that this expression is equal to 4. But we also have that the present value of the assets is equal to the present value of liabilities, because assets and liabilities are equal in value if we're using the immunization strategy. So we get this system of equations, two equations with two unknowns. And now your job is just to solve the system of equations, whichever way you like, but it's two equations, two unknowns, linear equations. Hence we get this system of equations that looks like this. A times 1.05 to a negative 2 over 1.05 to a negative 4, that comes from bringing it from the other side, times 2, plus B times 1.05 to a negative 6 over 1.05 to a negative 4, times 6. But that's the same as A times 1.05 squared times 2 plus B times 1.05 to a negative 2 times 6. That's equal to 24,000. And A times 1.05 squared plus B times 1.05 to a negative 2 is equal to 6,000. Let's write x for A times 1.05 squared and B times 1.05 and negative 2. Let's write this as y. Then the system of equations is 2x plus 6y is equal to 24,000, and x plus y is equal to 6,000. From the second equation, y is equal to 6,000 minus x. And we plug that into the first equation. We get 2x plus 36,000 minus 6x is equal to 24,000, resulting in 4x equal to 12,000, and x is 3,000. But x plus y is 6,000, that means that y is also 3,000. So A is equal to x times 1.05 to a negative 2 from the definition of x, and that's 3,000 times 1.05 to a negative 2, and B is equal to y times 1.05 squared. That's 3,000 times 1.05 squared. And then the absolute value of the difference of them is the absolute value of 3,000 times 1.05 to a negative 2 minus 3,000 times 1.05 squared. And that's approximately 586.41, which is answer D. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.